Okay, section 4.2. Yesterday, or in the previous video rather, we were introduced to quadratic functions, specifically how those graphs look like parabolas, how to tell from the equation whether it's opening up or down, and how to find the vertex and axis of symmetry without using the calculator. We also need to be comfortable with when we're looking at word problems that you can identify those key phrases like find the greatest, least, highest, lowest, that's really just asking you to find like either the x coordinate or y coordinate of the vertex. Okay, it's just a hidden way of asking you to find the vertex. As we move through these next sections in chapter 4, we're going to be in each section kind of unveiling a new technique or a new strategy for how to solve quadratic equations, and we're going to start with the easiest one, which is using what we call the graphing method for solving quadratic equations. This particular method is something that you need a calculator for. Okay, so you want to make sure you have your calculator out and handy here today. I have included for you the steps that you will be using on your calculator right here. So when you hear me talk through these key presses with you, all of that is listed right here. One important thing worth noting is when we are solving these quadratic equations, there are lots of different synonyms that all mean the same thing. Okay, so your solutions to a quadratic equation can be called roots, they can be called zeros, and they are also referring to the x-intercepts. So if you just think of a parabola, we know that, let's see here. Right? Whatever the x-coordinate is here to those x-intercepts, those values represent the solutions to your quadratic equation. Okay, those are also referred to as the zeros because those are the points where the y value is 0. Okay. All right, so when you're solving these equations by using the graphing method, there is not a lot of work that you need to show. Okay. In fact, you really just need to kind of set the problem up. What you have to do is you're going to want to graph the parabola in a window so that it is visible and you can see all of the x-intercepts. Now, keep in mind, when you type something into your calculator to graph, you always go to the y equals button. So what you have to make sure first is true in your equations is you need to make sure that all the terms in your equation are all moved to one side of the equation, leaving a 0 on the other side. Now, that is done for you here in example A, but in example B and C, we first need to kind of move everything to one side of the equation. It's preferred that you write it in descending order, but not required, although I would highly advise it. Okay, so in example A, since we already have everything moved to one side, what we would then do next, if we were going to solve this by the graphing method, what we're after is we want to be able to graph the parabola on our calculator screen, and then we're going to use our calculator to find those x-intercepts, and those x-intercepts will then be what we would report as our solution. Okay, so on the calculator here, I'm just going to switch over to the calculator. What you're going to want to do is you're going to want to press the y equals button. You're going to want to clear out any old equations that you might have had stored in y1, and then you will want to type the equation that you are given here for this example, which I believe is x squared minus 3x minus 4. Okay, I typically like to start with a -10, +10 window. You can either just go into the window button and adjust that yourself manually, or a quick way of making it -10 to +10 if it's not that, is to press the zoom button and choose option 6 for Z standard, and that will automatically graph in a -10, +10 viewing window. Now keep in mind, according to our step 1, it says you want to graph this in a window so that you can see all the x-intercepts. Okay, the maximum number of x-intercepts that a parabola could have is 2. Okay, so this is a great window for us for this problem. Okay, I'm referencing what's on your notes page right now. Step 2 says for you to press the second button. So we're going to press the second key. We're going to press the calculate menu. That's really this trace button right here. Okay. And then you're going to choose the option here. And I want you to think about what option would make the most sense if we were looking to calculate the x-intercept. Remember up above on the notes, we have different synonyms. One of those synonyms is zeros. So you want to come down to option number 2 and you want to pick zeros here. Okay, I am now on step number 3 on the notes page. It says move the cursor to the left side of the first x-intercept and press enter. Okay, so the first x-intercept would be right here. So I want to take this cursor and I'm just going to press this left arrow button, and as I do it, it's moving the cursor to the left. You just want to move it so that you're confident that that cursor is sitting to the left of where the x-intercept is. When you're confident, you're then going to press the enter button. Now, if you notice, when I hit the enter button, and this is kind of blending in with some of the pixels from the graph, there's this little arrow that's kind of pointing to the right that showed up right above where my cursor was. Okay, what I'm telling the calculator is I think that this parabola is crossing the x-axis somewhere to the right of this spot right here. Now, if I'm at step number 4 here on the notes, it says swing the cursor so it is just a little bit on the right-hand side of that first x-intercept and press enter. You don't want to bring the cursor all the way over here. You just want to tap the right arrow so that you're confident that it looks like, okay, now this cursor, if I were to drag it straight up vertically, it is to the right of where that x-intercept is. Now I want you to pay attention to what happens right above here on the screen when I hit enter. Okay, right here, and again, part of the pixels blended in with the y-axis, but an arrow now pointing to the left showed up. This is our way of telling the calculator we're narrowing down somewhere in between those two arrows is where we think the x-intercept is. Okay, step 5 says move the cursor to the x-intercept and press enter. So you're just going to drag the cursor over and just try to get it as close as you can. This is fine. To the x-intercept, you're going to press enter one last time, and it should tell you right here as the x-coordinate what the x-intercept is. And sometimes this is a big long decimal. You can just round it to 2 places if it doesn't come out to a nice perfect number like this is. Okay, so that is the point -1, 0. Okay, so I'm just going to switch back to my notes here, and I'm going to write down that one solution is the point -1, 0, which means x equal -1 is a solution. Okay, there's not really any work for me to show on my paper. I'm doing all of it on the calculator. You have to repeat that same process for the other x-intercept. So you're going to go to second, calculate. You're going to pick option 2 for 0. It is important that you are moving the cursor the correct way. It will prompt you down here in the bottom left corner. It says left bound. That means when you go to do the x-intercept, you need to make sure that you always start by having your cursor on the left-hand side of the x-intercept that you're finding. Okay, so now I'm looking to find this x-intercept. I want to make sure that my cursor is to the left of that x-intercept, and this is probably good. So I'm going to go ahead and hit enter. You can see right above there is my arrow. Now look at the prompt. It says right bound or right boundary. So now you're going to move the cursor so that you're confident that the cursor is now on the right-hand side of that x-intercept. Okay, oh, this is kind of a little delayed here. I'm sorry, it's just kind of slow going here with this. Let's see. Okay, I'm going to give it a few more taps here so that I'm confident that, yeah, okay, now this is definitely to the right. I'm going to hit enter, and then when it says guess, just give it your best guess and move the cursor down onto or close to the x-intercept. Press enter. It'll pause for a moment, and then it will give you the x-intercept. Now this is important. I want you to see this over here. This should always be 0. Now see this E right here? This means that this number is in scientific notation. This is saying it's the number 1 times 10 to the -12th power, okay? That is a number that means if you were to take the decimal point on 1 and move it 12 places to the left, it is so small that it virtually rounds to the number 0 anyhow. Okay, our answer is actually the x-coordinate anyhow. So I'm going to go ahead and write this as the point 4, 0. okay? All right, we're going to try just one more of these, okay? Let's take a look at example B here, and then we'll go down and try one for example 2. Okay. Now, there's a little bit of work that you have to do on the front end for this, and that is everything does need all move to one side. It does not matter which side you choose to move things to. I'm going to move things over here to the left side, but when you move this over to the left side, let's see, I believe this is going to be -9 there. You do need to show the equation that you have typed into the calculator. It also would be fine if you typed in, I guess if everything were moved to the other side, a positive x squared minus a 6x plus a 9. Okay, that's also fine as well. Okay, so we've got negative x squared plus 6x minus 9. That's what I'm going to type into y equals. Negative, whoops, let me clear this out here. Negative x squared plus 6x minus 9. Now, it does make a difference. This parabola that I'm going to graph right now is going to open down because my lead coefficient, the a, is negative. If all of these signs were flipped the other way, then the a would be positive and it would open up. But what I'm really after, I'm not trying to find the vertex. I'm trying to find the x-intercepts. And the x-intercept would be the same, okay? Now, I want you to look closely at this particular graph because you'll notice that in this particular graph, it almost looks like maybe instead of having 2 x-intercepts, it's possible that this graph only has 1 x-intercept, and that x-intercept is happening right at the U-turn where the vertex is located, okay? I'm going to do the same steps, though. I'm going to go to second calculate. I'm going to pick 0. I'm going to make sure I follow these instructions, left boundary. So I'm going to move this cursor so it's a little closer to the x-intercept, but that it's still staying to the left of the x-intercept. And now my prompt in the bottom left corner says right boundary. So I'm going to move the cursor over to the right-hand side, press enter, and for guess, I'm just going to move it directly on top of and hit enter. And this is going to give me, let's see. Okay, I got 0 there. Now this, I'm just going to round this to 2 places. And since this 9 repeats, I'm going to round this up to the number 3. This is crossing at 3, 0. And I only have 1 answer for this, not 2, because there was only 1 x-intercept. Okay, I want to look at one more with example 2b with you. Okay, so if we could, on the calculator, we're going to go ahead and go into y equals one last time here. We're going to go ahead and clear out y1. Let's type this in, negative x squared minus x minus 10. Okay, I'm going to press zoom 6. Okay, I will tell you, if when you graph this, if you feel like, oh, I'm not seeing all the parabola, then go back in, maybe adjust. Oh, here, we're hardly seeing any of it, aren't we? We're just seeing, I don't know if you caught that. There's a few pixels right here. This must be the top of the parabola, maybe. So here's a great example. I can't really see the x-intercepts in this. I can barely even see the parabola. I need to go down a little farther. This is only going down to -10 on the y-axis. I need to stretch down further, so I'm going to change the y-min to my window of going down to -20, and I'll see if that helps me see this parabola anymore. Okay, so this shows me a little bit more. Okay, but what I'm after, remember, is I want to know what are the x-intercepts of this parabola. Well, if this parabola is opening down, it's not going to cross the x-axis at all. So anytime your parabola does not have any x-intercepts, then that means this particular quadratic equation does not have any solutions. So you're just going to write down no solution. Okay, want to look at one word problem with you. We're going to look at example 3. It says a package of supplies is tossed from a helicopter at an altitude of 2,000 feet. Okay, altitude just means that's how high the helicopter was above the ground. It says the package's height above the ground is modeled by this function where t, that's our x, is the time in seconds. So our y variable, which is the h of t, that's our height. Okay, the question is, how long will it take the package to reach the ground? Okay, so I want you to think about a parabola here. Okay, we're going to pretend that the helicopter is right here at this red star that I have drawn, and that they're flying along here, and they dump this package out of the helicopter. Keep in mind our x-axis is time and the y-axis is the height. The question is how long, so this is asking for x, will it take the package to reach the ground? So in other words, the height of the package would be 0 feet above the ground. If I asked you to point in this picture, where does it represent the package landing on the ground? I think we all would say right there's the spot. Okay, this is when it has reached the ground. So what we're after is we are after what the x coordinate would be of this x-intercept. Okay, well, that's what we've been doing. We've been just graphing these and finding the x-intercept. Let's go ahead and hop onto our calculator here. We're going to go into y equals. We're going to clear that out. We're going to type in negative 16x. Oh, sorry, I didn't clear that out here. Negative 16x squared plus 28x plus 200. All right, when I see that 200 number, that makes me think that if I graph this in a negative 10, positive 10 window, I'm probably not going to see the parabola. Ooh, you see this vertical line. Okay, what this means is we are zoomed in so close on this parabola. It is a little hard, even though, yeah, we can kind of see these x-intercepts here. You're going to get really frustrated with this window if you just go into second calculate 0. I would encourage you to broaden out your window, and there is a really quick, easy way to get a good window instead of just like gradually making it bigger and then checking and making it bigger and oh no, I need to go even bigger. If you go into your table, and I'm going to go into table setup first. I'm going to start the table out at 0. Then I'm going to go into the table. Remember, these are all points that are on that graph. What I want you to look at is, do you see how these x values are not getting very big at all? But look how huge these y values are. This is giving you a hint for how you should adjust your window. We need to set the y part of our window really, really large, like up into the 200s and negative 200s. But we don't need to set the x part of our window that dramatic. So let's go ahead and go into window. And for the moment, I'm just going to leave the x part of the window as negative 10, positive 10. But I'm going to change the y part of my window to negative 250, positive 250, and I'm going to count by 25s. Now hit graph. This is going to be a much better window. Look how great that parabola looks. You can really see the parabola well, which is also going to make finding this x-intercept much easier. We don't need to find this one because this was a word problem. We're only interested in time that's positive, not time that's negative. And so then we go to second, calculate, we pick option 2 for 0. We do the same thing that we have been doing, which is we want to move the cursor so that it's closer to the x-intercept, but still to the left side of the x-intercept. Okay, so I'm getting closer here. I'm going to go ahead and press enter. And then I want to move the cursor so that it's on the right-hand side of the x-intercept. Okay, so I need to kind of move it over here. Okay, now it's to the right. I'm going to hit enter, and then I'm going to guess by moving it on top of the x-intercept. Whoops, and hit enter. Okay, my answer will be this x-coordinate. I'm going to round it to 2 places and say that if they threw the package out the helicopter, in order to be 0 feet above the ground, which means it's landed on the ground, it's roughly going to take 4.52